right, our final lesson from the chapter, solving rational equations. Now remember, this is equations, not expressions, hence the equal sign. Now solving, so we're trying to figure out what values of x makes the statement true. Okay, so that's what we're solving. Now, we have to remember though, with rational equations, we have rational expressions in there. And with rationals, we have domain restrictions. The idea is we have to go through the restrictions, because if when we're solving, we come out that x equals that number, well, we already know it can't happen, so we would cross it out and it would not be a solution. So when we first solve, what we're going to do is factor and then do domain restrictions, okay? So, and remember, domain restrictions are when the denominator equals 0, because then the whole thing would be undefined since we can't divide by 0. So here's how we're going to do domain restrictions first. Here's an example for you. So first we're going to factor. As you can see, this is already factored. Then we're going to take the denominator, set it not equal to 0, and solve. So in this equation, x cannot be -4. Otherwise, we would have an undefined answer. So let's just practice that now. In A here, everything's factored. So I see that in the denominator, we have x plus 5. Set it not equal to 0. So x cannot equal -5. In B, okay, I see this right side, left side. Left side is factored, but on this right side here, I need to factor this. Now, of course, I'm going to factor it really quickly. You can do it by your box or your groupie. Now, I see that they both denominators have an x plus 8. So, of course, x plus 8 cannot be 0, making x not equal to -8. And then I have one more thing in that denominator, which is this 2x minus 1. Set that not equal to 0. And then we solve. So 2x cannot equal 1, and x cannot equal 1/2. And we're done. So in this case, for B, we would have 2 domain restrictions that we would have to check. So that's just your domain restriction. When we're actually solving, as you can see here are our steps that you can follow each time. We're going to factor everything. We're going to find our domain restrictions. Then what we're going to do is clear the fractions pretty much by common denominators, which we just did in the last section. And we're going to look at the numerator and simplifying it, resulting in an x equals. Then we compare our answers with the restrictions to make sure everything works. So here's an example I'll show you together. Here's our equation. First thing we're going to do is factor. So the first one's factored, and here we can take an x out for greatest common factor, Yes, I said it right. Then we're going to find our domain restrictions. Okay, set each piece of our denominator equal to 0. So I see I have this x plus 3, so I'm going to set that not equal to 0. And I see I have this x and set that not equal to 0 and solve. This one says x does not equal -3, and this one's already there. I don't have to worry about everything else because I already had those pieces. Now, this looks a little confusing here, and I'll show you why in a minute, okay? So I'm going to rewrite our factored equation because our next step would be to find a common denominator. And we're going to do that just like we did in section 2.3. So in other words, I'm going to ask myself what's missing. I'm also going to group that x plus 3 because that's together, right? So what is missing from this first denominator that would make it consistent with the other ones? Well, it's missing an x. And whenever I do the bottom, I do to the top. All right, remember, it's grouped together. So what I'm missing is this parentheses x plus 3. And whenever I do the bottom, I do to the top. Now our denominators are common. So the reason why you see all this crossing off above is because the idea is, since they have common denominators, they actually cancel those denominators out. So you'll hear me as we go through the lesson that I might say, ignore the denominator and focus on the numerator, because the idea is the denominators cancel out when solving. Okay, so since you have a common denominator, then we can focus on the numerator. So you see how the numerator here is 2x plus 3 parentheses x plus 3 equals 10. And now we solve like we usually do in algebra. We'll distribute first. Distribute, combine like terms, and then get x by itself, and we find that x equals 1/5. Okay, so we simplified right there. But the last step, what you need to keep in mind is you need to compare with your domain restrictions. So luckily for us, none of our restrictions is 1/5. So this is our final answer, and we are all done. Let's try working on some of those together. Excuse me. So what I'm going to do is factor first. Sorry, guys. Now I know none of this looks factorable, but I am going to break down that 6 because I know it has a connection with that 3. So I have 2 over 3 minus 1 over x equals 5 over, and let's think of that 6 as 3 times 2. And that will help us better see what we're missing. So I see in the first one, our denominator is missing a 2 and it's missing an x. Do you guys see that? A 2 from here and an x from here. Whenever I do to the bottom, I must do to the top. Okay, well, what's the next one missing? Well, the next one is missing that 2 and that 3. Well, what's 2 times 3, guys? 6. Whatever I do in the bottom, I do in the top. What's that third one missing? An x. Whatever I do in the bottom, I do in the top. Oh, I forgot a step, didn't I? I forgot the domain restrictions. So before I continue, let's look at these denominators here. Can 3 ever be 0? No. Can x ever be 0? Yes. So we have a domain restriction that x cannot equal 0. Can 6 ever be 0? No. So that's our only domain restriction. Hopefully in the future right now, I remember to do that step second. Okay, go back to what we just did. Common denominators. You see that? Whatever we did to the bottom, we did in the top. Okay, now because our denominators will cancel out with each other, we can ignore the denominators and look at our numerators. So I have this 2 times 2x minus 1 times 6 equals 5 times x. Now I know most of you might have already done that multiplication. I'm just doing it step by step. So I get 4x minus 6 equals 5x. All right, I don't have to distribute combine like terms, but I do need to get x by itself. X is on both sides. So I am going to move that over. So I get -6 equals, I'm gonna subtract the 4x from both sides, so I get x. So x is -6. And then I'm gonna compare my domain restriction, and I can see that they're not interfering with each other. So x equals -6. Okay, let's try that again. First step, factor. So 3 over x plus 2 plus 1 over x minus 2. Those are already factored, so we're good. Equals x over. Now, if you remember, this is the difference of squares. So this is x plus 2 times x minus 2. It's great. Look at, because there's some commonality there. So that's great. Domain restrictions. Yay, remembered. Okay. Set each of our denominators not equal to 0. Now, as you can see, because these two denominators are already there, that covers these two. So solve. So x cannot be -2, nor can it be 2. All right, domain restrictions are done. Next is common denominator. So let me group these together so I don't get confused. So the first one is missing this x minus 2. The second one is missing x plus 2. But whatever I do to the bottom, I must do to the top. Now, do they have common denominators? Yes. All right, next, we can ignore our denominators because they cancel. So let's look at our numerators. We have 3 times x minus 2 plus 1 times x plus 2 equals, and we didn't have to do anything over here, so we just have x. Distribute, right? Because that's distribute, so you know what you're doing. 3x minus 6 plus x plus 2 equals x. We're going to combine like terms now. So we get 4x minus 4. Now, what I'm going to do, guys, is I'm going to move this x to the left side and this 4 to the right side. So I'm going to subtract x from both sides. That leaves us with 3x on the left side. And I'm going to move this 4 over. I move it by adding. So x equals 4/3. Last step, don't forget to do this, compare. Did we run into anything? No, we didn't. So there's our answer. Great, let's do one more before I have you do some practice on your check, okay? I like doing this one since that one is there. Okay, let's look. Are we factored? Yes, we are factored. I'm actually going to rewrite this though, so I give myself room. Now I'll show you why in a minute. Now, what I'm going to do when I rewrite this though, is as you can see, 1 as a fraction, so we're talking about numerators and denominators, is 1 over 1. Okay, so be careful there. Domain restrictions. So our denominator here is x minus 1. Set that not equal to 0. Denominator here is x plus 2. can't equal 0. And 1, well, 1 can't equal 0, so we're okay. So let me solve these. So we don't want x to be 1, and we don't want x to be -2. All right. Remember the next step? Common denominators. So I already grouped them together, so that's good, so I don't get confused. Because this one is missing an x plus 2. Whenever I do the bottom, I do the top. This one's missing an x minus 1. Now look, you also have to include this over here, because this denominator is 1. That means it's missing this x plus 2 and this x minus 1. Now you might be wondering why I didn't put 1s with each of these. Well, because anything times itself is 1. Now if that were 2, then I would put a 2 with both of these. But it's not, it's a 1. Anything times 1 is itself. All right, let's not forget whatever we do in the bottom, we must do to the top. All right, do they look like each other now? Perfect. So let me focus on that numerator, 2 times x plus 2 plus 2 times x minus 1 equals x plus 2 times x minus 1. Take a moment. My next step here, I'm going to distribute that out, right? Distribute that out. But here, guys, just remember to do your box. So multiply. Some of you FOIL. Most of you do the box method. So do your box then. That gives us 2x plus 4 plus 2x minus 2. Now on the other side there, I'm going to do the box quickly. And remember, x plus 2 times x minus 1 gives us x squared, 2x, negative 1x, and negative 2. So equals x squared. Well, 2x and negative 1x is a positive x and negative 2. Now, I want to give you a clue right here. When you have a squared and x squared, 1, it means more than likely you're coming out with 2 answers, which means you're going to factor. Okay. So if you have an x squared, what I want you to do after combining like terms is to move everything on the side with that x squared, specifically positive x squared. So let me combine like terms. I have 4x plus 2 equals x squared plus x minus 2. And now remember, I just said move everything on the side with that x squared. When I do that, I get x squared. So I would be subtracting that 4x, right? So x minus 4x is negative 3x. And 2, subtract that over, right? So negative 2 minus 2 is negative 4. Now we have a trinomial. We can factor it. I'm going to factor it quickly. You factor it by your box, by your grouping, whichever you like. So when I factor it, I get 0 equals x minus 4 times x plus 1. So my solutions, well, what makes this part 0, right? What makes it 0? 4. And what makes this 0? Negative 1. Compare. Compare with your domain restrictions. Do they interfere with each other? Nope, we're good to go. So in this case, in example 4 here, we have 2 solutions and they both work. That will happen with the square, but sometimes one of these will not work. Now I would like you to do 1 and 2 on your check, just to make sure we got things going so far. All right, hopefully you've paused that video and you checked with me and you're on the right track. We got 1 more to do. What's that first step again? Factor. I'm going to factor quickly. So I get x minus 3 times x minus 4 minus 2 times x minus 3 equals 5 over x minus 4. Domain restrictions. It looks like it's just that x minus 3 can't equal 0, and that x minus 4 cannot equal 0. So that means x cannot equal 3, and x cannot equal 4. Common denominator. Okay, what's missing? Well, it looks like that first one has both parts, and this one's missing an x minus 4. Right. Let's do that to the top. This one's missing a x minus 3. Do that to the top. Now, do we have a common denominator? Yay, we do. All right, let me look at the numerator. 5 minus 2 times x minus 4 equals 5 times x minus 3. Distribute. I'll write down that so you remember what to do. Distribute. So we get 5 minus 2x plus 8 equals 5x minus 15. Combine like terms. Negative 2x, what is that? 13 equals 5x minus 15. All right. Some of you like to move your x's all the way to the left side, no matter what. Some of you like it where you have a positive x. I like the positive x. So what I'm going to do is move this 2x to the right side, leaving us 13 equals 7x minus 15. Then I have to move that 15 over, right? So we get 28 equals 7x. Divide by 7, we get 4 equals x. Awesome. Last but not least, compare. Uh-oh. We have a solution that is a domain restriction. This is what, at the beginning, if you read that paragraph, we call an extraneous solution. So right off the get-go, we know that 4 can't happen. So when this happens, what I want to do is I cross that extraneous solution out. Okay, so cross out that extraneous solution. Now in this case, we have no other solution. Well, if we have no other solution, that means there is no solution. Sometimes, if we go back to example 4 here, we have 2 solutions. One of these might be extraneous. So when you answer the question, you would cross out the extraneous one and just give me the one value. But in example 4, both of them worked. In example 5, our one answer did not work because it was an extraneous solution. All right, now do the last one on your check. Check with me, and then you guys can do some practice on your own.